This is the fifth video supplement for CIS 343, Grand Valley State University's course on programming languages. This video discusses the use of symbols as data. So imagine you're writing a computer program. Let's say it's a server of some kind, and this server has to keep track of its status. For purposes of our discussion here, let's say it has 4 possible statuses: ready, busy, blocked, and error. What type of data do you use to represent this value? If you have a variable named current status, what do you assign to this variable? Now, assuming all we need to do is distinguish the 4 statuses from each other, by that I mean assume that all we need to know is that ready is not the same as busy is not the same as blocked, then the simplest solution is to simply assign each status a unique integer. Now, you can imagine how using these integers explicitly could be annoying and even hinder readability and, to some extent, writability. Right? Imagine being the new guy on the team and having to repeatedly look back to the top of the file to remember whether 2 means busy or blocked or error or whatever. Well, one common approach to improve the readability and writability of this situation is to define some constants and then use those variable names. By defining constants and giving them each a unique integer, we can use the name throughout the rest of the code instead of simply trying to remember the number. However, think for a minute about what it takes to use this technique if you have a wide range of concepts that you're incorporating into your program. For example, imagine you're writing a program that will include statuses and months of the year and days of the week and maybe makes and models of cars and so on. Somewhere in your program, you'd have to maintain a long list of constants, and you would need some process to make sure that the integer for each constant was unique. Languages derived from LISP, including Scheme and Kawa, automate this process by allowing you to use any symbol as a value. For example, suppose I have a function called report status. The actual behavior of this function isn't important. The only thing you need to know is that we tell this function whether the status is ready or blocked or error or whatever. So when I call the function, I can pass the status this way. Here, I'm using the name blocked as a symbol, as a unique idea. There's no explicit value to the symbol. The only thing Scheme knows is that each symbol is distinct. Ready is different than blocked is different than error. Notice the single quote. The single quote distinguishes this name as a symbol as opposed to a function name or the name of a bound value. If I had omitted the single quote, Kawa would respond with an unbound location error, essentially complaining that the name blocked doesn't refer to anything. Actually, the single quote is a shortcut for the quote operation. Instead of single quote blocked, like I have here, I could have also written the call to report status this way. Using symbols is common enough in Lisp-like languages that it's nice to have that syntactic shortcut, makes the code a little easier to write, and it's a common enough thing to do that it really doesn't hinder readability. So apologies for making a short story long. The bottom line is that Lisp and derived languages allow you to reference an abstract idea by simply giving it a name and putting a single quote in front, or using the quote operator. Actually, one last thing. Let me quickly point out that another alternative to using symbols is to simply use strings. I could have written the report status function to expect a string instead of a symbol and then called it this way. At a high level, the main disadvantage of using strings is that it takes more resources to store and compare strings than it does to store and compare the integers that tend to underlie symbols. However, there are a number of optimizations that can be utilized when the strings are hard-coded into the program, typed in literally with quotation marks like we see here. So using strings as symbols is not entirely unreasonable. Fully interpreted languages already have a fairly high overhead compared to compiled languages, so the differences between symbols and strings for these languages is often very small. Compiled languages are often statically typed and therefore use enumerations, which allow for more thorough error checking. I'll discuss enumerations in more detail later in the semester. I first came across the concept of symbols when I learned Ruby. Ruby symbols work pretty much the same way, except you use a colon instead of a single quote. I remember it took me a little while to understand why Ruby bothered with the symbols instead of just using constants or strings. That's why I made an entire video instead of simply saying, you can put single quotes in front of names. So if you also find this concept a bit confusing, don't hesitate to ask lots of questions.